Okay, our next topic for the course is cryptography. We're going to start out with something called the Caesar Cipher. We'll talk about that in a second. So, cryptography is something that you may not think of as being mathematics, but in fact, it very much is. It's also something you may not think about as being something you use very often, but in fact, you use it all the time. So, just to talk a little bit about cryptography, just a little bit of terminology in first. So we're going to talk about encrypting or encoding messages and decrypting or decoding messages. So what cryptography is the study of how we can make something secret, how we can make something unreadable, and then make it back to something that is readable. So encrypting is the process of putting something into code. Decrypting is the process of taking it out of code so that somebody can read it back in regular language. Um, and so, why is cryptography important? Well, um, up until about 20 or 30 years ago, it wasn't actually that important for most people. So, when you think about cryptography, a lot of people think about like spies and military secrets and things like that. And in fact, up until 20 or 30 years ago, that was kind of how it was used. And then a little bit of an invention came along called the internet, and suddenly cryptography became incredibly important for everyone. Okay? So, cryptography is what we use to send any kind of information that we want to keep secret over an open channel. And so, with military secrets, that was always like sending a letter through the mail or talking over a radio signal. Nowadays, anything you send over Wi Fi or anything that goes out over the internet, that can be seen by anyone who intercepts that communication. And so, if your phone is connected to a wireless signal, anybody who's nearby can pick up what your phone sends out. It's just broadcasting it for the Wi Fi antenna to pick up. They can pick that up, but they can't read it. They can't understand what it says because it's encrypted. It's been put into a code like this. Um, any information you send out over the internet, same way. Someone actually has to physically intercept it. They have to be at some spot on the internet in between you and wherever you're going, but that's not hard to do either. And so if you send out your credit card information or a password, those are always encrypted. They're put into a secret code so that only you and the person you're sending them to can read them. Now, those codes that are used on the internet are tremendously complicated. They are mathematical. If you want to read about them, you can read about them in the textbook. It's a cryptography called the RSA cryptography, but we're not going to go into it in this class. We're going to talk about some much simpler codes that have been used for a long time, starting off with what's called a Caesar cipher. So this is named after Julius Caesar. Julius Caesar used one of these to encode all of his letters. And what we do in a Caesar cipher is we just shift every letter in a message over by a certain number of characters in the alphabet. Okay? So, for example, a Caesar cipher with a shift of 3 would take every letter in the alphabet and move it over 3 letters. So A would go B, C, D, would be changed into a D. B would be changed into an E. C would be changed into an F. D would be changed into a G. E would be changed into an H. And you would keep on doing this with the entire alphabet. And so the easiest way to keep track of this is just to write out the whole alphabet. Which I think I have room for here. And then write down what each letter goes to in the alphabet. Okay? And so you'll notice toward the end, I get to W goes to Z. What is X going to go to? Well, we start back over at the beginning so that we've got something to shift these last 3 letters to. So X is going to go to A, Y goes to B, and Z goes to C. Okay? And so now everything has been shifted over by 3 letters. Okay? So you can do this with just letters. You can do it with letters and numbers. I'll do my next example with letters and numbers so you can see one of those. But what we do is if we want to encode a message, so say our message is something like attack at dawn. Well, we would take the A becomes a D, the T becomes a W, C becomes an F, K becomes an N, and we just replace each letter with the letter below it. D goes to G, W goes to Z, N goes to Q. Okay, and so we get the encoded message DWWDFN, DWGDZQ. And so now this is encoded. Nobody can understand what the message means. If you want to decode something, you go the reverse way, right? So if you wanted to decode this message, you would say, okay, D, look in the bottom row, what letter did that come from? So D came from A. W, find it in the bottom row, came from T. D came from A. F came from C. N came from K. And you can see you get back your original message. So to encode, you go from the top row, the original alphabet, down to the shifted alphabet. To decode, you go backwards and go from the shifted alphabet back up to the original alphabet that you started with. Okay? So let's look at another example with a alphanumeric. So alphanumeric means letters and numbers. So let's do an alphanumeric Caesar Cipher with a shift of, let's say, 10. Okay? And so oftentimes when the shift is by a particular number, I'll give you a lot of times in the homework assignment, rather than just saying a shift of 10, I'll say that A goes to whatever letter it goes to. So A would go to B, C, D, E, F, G, H, I, J, K. So A goes to K, and that tells you kind of where it starts. So we're going to do an alphanumeric cipher. So I'm going to need a little bit more space here. So I'm going to write down the whole alphabet. But this time I'm also going to do the numbers 0 through 9. Okay? So you maybe can't quite see on the board, but I've got the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 over here. A is going to go to K. Everything else just kind of falls into place. But this time, when we get to Z, we're going to replace the next letter, Q in this case, with 0, R with 1, S with 2, T with 3, U with 4, 5, 6, and then start back over at the beginning. So 0 goes to A, B, C, D, E, F, G, H, I, J. Okay? And so now in this code, if we replaced, say, attack post 587, right? Now we can encode something that also has numbers in it. And so A goes to K, T goes to 3, A goes to K, C goes to M, K goes to U, P goes to Z, O goes to Y, S goes to 2, T goes to 3, and then 5 goes to F, 8 goes to I, and 7 goes to H. Okay? So be careful when you're doing this. Make sure you write these in such a way that you can tell which one is which. So notice here I crossed my Z and put a loop in my 2, just so that I really can see this is a Z, this is a 2. I write my I in all capital, so I don't get it confused with L or with 1. So just be careful is all. Okay? And so that's encoding a message. Decoding, again, you go from the bottom row back up to the top. Okay?